Hello everyone and welcome to Math Steps. Today we are going to learn about relative frequency and solve problems accurately. Now, relative frequency, it is often calculated after performing experiments. So it relates to, remember this word relate, it relates to experimental probability. And the methods of finding the relative frequency, the strategy, the methods, strategies are exactly the same like when you find the experimental probability. Right, so let's have a look at one example. It says, in a survey of 200 students, 28 said they were vegetarian. What is the probability that a person picked at random will be vegetarian? So of course, there is 28 over 200. And if you simplify this with the denominator 100, and it's going to be over, so 14 over 100 or 14%. So 14%. And if you want to express this as a decimal number, it's going to be, the answer is going to be 0.14. So there is a 14% chance that the person picked at random will be vegetarian. But just like that. So the more people they are asked, the more accurate the relative frequency will become. Example number 2. Fred records the colors of 100 cars that pass his house. His results are shown below. Calculate the relative frequency or experimental probability for each color. Now, of course, as always, you need to find the total. But in this case, we have the total. There is 100 cars in total here. 100 cars. And to be able to find the probability that the next car to pass his house will be red, then of course we're going to do 10 divided by 100, okay? Because there's the frequency is 10 cars passing. That's what Fred recorded. So it is 10%, obviously, or express this as a decimal number, the answer is going to be 0.1. For a blue car, as you see, 15% chance, 15% or 0.15. Not black, not black. Now here, you can solve this. I'm going to draw a line here to show again both methods. You can solve here by complement. So you can say 1, take away now the probability of having a black car passing the house is 0.32, so not black is going to be 1 minus 0.32, and the answer is going to be 0.68. Or not black, you can add, see, not black, that means it's going to be red or blue or silver or other. So you can add all of them together, 10 plus 15 plus 32 plus 5, and the answer is going to be 68, 68 over 100. Of course, we are going to have exactly the same answer as when we use the complement method. On an average day, 3,500 cars pass Fred's house. Based on his results, how many of these 3,500 would we expect to be silver? Silver here, so the probability of having a silver car passing Fred's house is going to be 0.38 or 38%. So if 3,500 cars pass his house, then the probability of having silver is going to be 0.38 times 3,500, and the answer is going to be 1,330 cars altogether. Okay, just like that. And here you have the answers. Now, exercise 3. It is pretty similar to the exercise we just had. Graham owns a vet. He records the animals that he sees over the course of the week in this table below. Calculate the experimental probability for each pet. We don't know how many was the total frequency. So in this case, the problem doesn't show it. So in this case, we have to find out. And that is by adding all the frequencies for each pet together. And the answer to this one is going to be 170. 170. Now, to be able to find the experimental probability for each pet, then we're going to have to divide 80. For example, for the dog, 83 over 170. Okay, for the hamster, 12 over 170. And for a cat or, it's a cat or a snake, that means 52 plus 3. So 52 plus 3 over 170. All right, so it's going to be 55 over 170. I'm going to let you now find these results in expressed in a decimal number, and not a dog, not a dog. And so the probability of having a dog is 83 over 170. And so over 170, if you express this as a decimal number, not a dog, is going to be 0.49. So not a dog is one, take away the 0.49, and the answer is going to be 0.51, all right? Or if you add all of these together, 83 plus 18 plus 12 plus 3 plus 2, the answer to this one, is going to be 87, definitely 87 over 170. And if you divide both of them together, the answer is going to be around 0.51. So we have exactly the same answer. C, over the course of a year, the vets sees about 8,400 pets. 8,400 pets. How many of these would Graham expect to be rabbits? Now, the probability of having a rabbit, seeing a rabbit, is 0.11. So the answer to this one is going to be 0.11 times 8,400. And the answer is going to be 8,400 times 0.11. So the answer is going to be 924 rabbits. It's the probability of Graham is likely to see 924 rabbits out of 8,400 pets over the course of a year. Okay, now here there are two exercises for you to work independently. You can use the method of a complement for some of them. Have a look. And here you have it's rolled 120 times, so you have the total here. And he says the probability that the biased dice lands on 4 is 0.475. Do you have this one, the probability of having a 5? So have a think. You need to find first the probability of having a number, and then multiply by the total, and so on. So just follow exactly the same strategies, and thank you very much for watching my steps. Have a good day. Bye-bye.